All right, so today we're going to be talking about graphing systems of linear inequalities. Yesterday, you learned how to graph just one inequality. Today, we're just going to put two on the coordinate plane. Once you graph those two inequalities, you're going to see that the shading will overlap somewhere on your graph. So you can see that that would be this area right here. That's overlapping. So this shaded region here would be our solutions. And then, of course, anything on this solid line would also be a solution. We talked about that yesterday. So jumping into some practice, we're going to tell whether the ordered pair is a solution. We're going to do the same thing that you did yesterday. We know that that first number is x and the second number is y. So we're going to put in 0 for x and 0 for y and see if it's true. Now, in order for this to be a solution, it has to work with both inequalities. So I'm going to put a 0 in for this y and then bring everything else down. Greater than 2. Is 0 greater than 2? No, it's not. It's less than. So I don't even have to check that second equation, or sorry, inequality. I'm done. It didn't work for the first one. It has to work for both, so it's not a solution. So on number 2, I have -1 for the x and 1 for the y. So in my first inequality, I'm going to put in a -1 and bring down my less than 3. Then ask myself, is 1 less than 3? Yes, it is. So now I need to check the second inequality to see if it is a solution. So I put a 1 in for my y, bring down my greater than, put in a -1 for the x, bring down my -4. Then I have to do a little bit of math right here on the right side. So I'm going to bring down my 1 is greater than. Now -1 minus 4 gives me a -5. Is 1 greater than -5? Yes, it is. Since this worked in both inequalities, this would be a solution. Yes. Okay, now I want you to try these on your own. So go ahead and pause the video and see if those are solutions to the inequalities. Okay, so you should have put a 3 in for your y. So 3 is greater than or equal to the x, which is a 2, plus 4. So that would give us 3 is greater than or equal to 6, which it's not. 3 is less than 6, so this would be a no. Sorry. Then on number 4, we're going to put a 0 in for the x and a 4 in for the y. So for the first one, we're going to do 4 is less than negative, and then I put the 0 in for the x, so 0 plus 4. So on the left, it's just 4 is less than or equal to. Adding or subtracting, it doesn't matter with a 0. It doesn't affect what you're adding or subtracting to, so this just stays a 4. Is 4 less than or equal to 4? Remember, it only has to satisfy one of those things. It is equal to 4. So this works. So we tried in our second inequality. So 4 is greater than or equal to 5, and then instead of times x, we're going to put in times 0 minus 3. So I need to clean up that right side. So 5 times 0 is just a 0. So this essentially just goes away because adding or subtracting 0 doesn't change anything. So I bring down that -3. Is 4 greater than or equal to -3? Yes, 4 is greater than -3. So I would say yes, this is a solution. Okay, how did you guys do on these two? Did you get them correct? Okay, next we have our graphing. So remember, when we graph, we want our equations to be in the form y equals mx plus b. Then in these cases, instead of an equal sign, we will have an inequality sign, but we still want to be able to have the y by itself so we can identify slope and y-intercept. Okay, so y is greater than -2. We did problems like this yesterday. If there's just a y, I know I'm going to have a horizontal line, and I know that horizontal line will be at the -2 on the y-axis. So down here at this -2, I have a point. Then I look at my inequality sign. It is just a greater than, not an equal to. So I know I'll have a dashed line. Then my shading, y is greater than, so I know I'm going to shade above. Well, I know I'm going to have more than one line on this grid, so I'm just going to draw arrows the direction I would shade. Okay, so there's not too much going on my graph, and it gets hard to read. Then my second equation, y is by itself, so I just can easily identify my slope and my y-intercept. My slope is the number attached to my x, which in this case is a 3. We do want to make it a fraction by putting it over 1, just like we did yesterday. Then my b value is whatever's not with the x. Since we don't see anything, we don't have a +3 or a -4, it's a 0. When we don't see anything added or subtracted, it's a 0. So I begin at b, so 0 on the y-axis, so right here. And then I move with my slope. I move up 3 and to the right 1. So up 1, 2, 3, to the right 1. Then my inequality sign shows me that it is equal to, so I'm going to have a solid line. Then y is less than, so I want to shade everything less than, so below this line. So once again, I'm going to draw my arrows. Now that my arrows are drawn, I can see these purple arrows and these red arrows are pointing to the same section of this graph. This is where our solution would be. This is where we shade. So our solution would be anything in this shaded green area plus whatever is on this red line from the intersection point all the way up. Okay, number 6, we have y is less than 3. Again, this is that horizontal line. So we're going to start on the y-axis at 3. My line, is it going to be dashed or solid? Good, it's going to be dashed because it's not or equal to. Then y is less than, so above or below. Good, we're going to shade below. So again, I'm going to draw my arrows. Then x is less than 2. We don't have a y this time, so we know we're going to have this vertical line. So on the x-axis at 2, I'm going to draw a point. Then will this line be solid or dashed? Good, it'll be dashed because it's not or equal to. And then are we going to shade to the left or to the right since x is less than 2? Which numbers are less than 2? -4, -2, or +4? Good, to the left. -4 and -2 are less than 2. So I'm going to shade to the left. And again, I can see my red arrows and my purple arrows are all pointing to this bottom left section of the graph. So this is where I would shade. So my solutions would be anything in that green shaded area. Okay, 7 and 8, I want you guys to see if you can try these on your own. So pause the video and try it out. Okay, on number 7, both of our equations are in y already, so we can find our m and our b. So on the first inequality, my m, my slope, is what's attached to the x. I don't see anything, so I know that's a 1. And again, we need to make it a fraction by putting it over 1. Then my b is the number without the x, so that would be this -2. Again, when I'm going to graph, I begin at b. So on the y-axis, I begin at b, so I begin at this -2. And then I move with my slope. So up 1 to the right 1. Up 1 to the right 1. So now I'm ready to connect my dots. Since it's less than or equal to, I know I'm going to have a solid line. So it's going to look something like that. Oh, sorry. Something like that. And then shading, y is greater than or equal. So greater than would be everything above this line. Okay, and then my second inequality, I can identify my slope. It's the number in front of my x, which this time it's a -1. So I make that a fraction by putting it over 1. And my b value is a 2. So I begin at b, so I begin at 2 on the y-axis. And then I move with my slope. I move down 1 and to the right 1, since that 1 is negative. So down and to the right, down and to the right. I'm going to connect my dots with my line. Since this is just less than, it's going to be a dashed line. And then we're talking about less than, so we're going to shade below. And then we want to actually shade where they have the arrows pointing in the same direction, which would be this area